Composition of functions. Figure 1 is a function machine that will help us illustrate the composition of functions. Suppose g and f are functions, and x is a number that is in the domain of g. Then, we can find the value of g at x. Now, suppose g of x is in the domain of f. Then, we can find the value of f at g of x. This correspondence from x to f at g of x is known as the composite function. The composition of the function f with g is denoted by this expression and is defined by the equation f with g at x equals f at g of x. The domain of the composition function is the set of all x's such that x is in the domain of g and g of x is in the domain of f. To further illustrate, let's have this. X is in the domain of g, while g of x is in the domain of f. So if we need to find the composition of functions f with g, all the x's in f shall be replaced with the value of g of x. To help us understand it, let's have some examples. Given the function f and g, we need to find f with g. Because f with g at x means f at g of x, we must replace each occurrence of x in the function f by g of x. Now in this line, this tells us the definition of the composition of function. Next step is to replace x in f by g of x. Our f of x is 3x minus 5. Thus, this x will be substituted with x squared plus 4. And thus, we have this line. Now, applying the distributive property, that is 3 times x squared is 3x squared. 3 times 4 is 12, and then copy minus 5. Simplifying, we have our final answer, which is 3x squared plus 7. Let's have another example. With the same given, we need to find g with f. Because g with f at x means g at f of x, we must replace each occurrence of x in the function g by f of x. Now, our g of x is x squared plus 4. So we need to substitute this x with 3x minus 5 and then copy square and then plus 4. That's why we have this line. Applying the special product, the square of a binomial, we have this 9x squared minus 30x plus 25 and then copy plus 4. And then simplifying, we have 9x squared minus 30x plus 29. Recalling the steps, we have replacing x in g by f of x. Next is applying the square of a binomial in the square of the quantity 3x minus 5. And then simplifying to have the final answer. Let's practice more. Given h of x equals 2x plus 3 and m of x equals x minus 5, find m with h. So for our solution, because m with h means m at h of x, we must replace each occurrence of x in the function m by h of x. Our m of x is x minus 5, so x in m of x will be replaced with 2x plus 3. So this is this step. Now simplifying or combining similar terms, we have 2x minus 2. Now it's your turn to answer. With the same given, you need to find h with m at x. If you are done answering, try to compare it if you get it right. So this is the answer. Now the x's in h will be substituted with m of x. So 2x plus 3 will become 2 times quantity x minus 5, which is the value of m of x. Applying the distributive property, we have 2x minus 10 plus 3, and then getting the final answer, we have 2x minus 7. Is it clear to you now? I hope so. This is all for now, and see you in the next lesson.